Started.
All right, the recording has started. You're good to go.
All right, awesome. Thank you guys so much for coming to our workshop. We're just going to be talking about a very quick intro to deep learning and TensorFlow basics, as well as some demos of using TensorFlow. So, all right, this workshop is presented to you by the Developer Student Club, powered by Google Developers. And all of the panelists here today are the exec team of the DSC. So let's do a quick introduction. I can start. My name is Brittany. I am a junior in Applied Data Sciences, and I am one of the technical directors of DSC for this year. And I'm gonna pass it on to Harsh.
Hey guys, I'm Harsh. I'm a junior majoring in computer science with a minor in engineering design. I'm also a technical director at Developer Student Club, and I really look forward to getting to know you all. Ciao.
Hey everyone, I'm Yankee. I'm the webmaster at Developer Student Club. I'm studying computational data sciences, and I'm a junior.
Hey guys, I'm Sasha. I'm a senior studying computer science, and I am also a technical director of the club.
We're going to talk a little bit about what Developer Student Club is and who we are and what we do. So basically, we are a university-based group for students that are interested in tech and tech development. Our club is open to any and all students, all majors, all backgrounds, doesn't matter. You don't even need to have a technical background. Our members usually range from anywhere from beginners who are just starting out in dev to more advanced students who just want to refine their skills or explore other tools and platforms. And we also have members from all sorts of different majors and disciplines. It's not just limited to ECS, IST, or engineering. We also have members from SMEAL, like econ majors and management information system majors. So I think we even have geography majors. So our club is just a great way to explore and try new things. In general, we just try to help students connect and learn and grow. We hope that our members can meet other people who share the same interests or peers from a completely different background and field and learn from that. And what we do in our clubs is we have a lot of professional networking and team building events, as well as tech talks with Google employees and professors. We also get a chance to explore Google developer resources. One of the main advantages of joining the Developer Student Club is that we get free access to GCP, which is the Google Cloud Platform. And if you join us, you're going to be able to use the cloud platform for free, as well as Qwiklabs, which is a learning platform provided by Google. So you'll be able to use all these services, no cost. And finally, another aspect of the Developer Student Club is the Google Solutions Challenge, and you can only participate in the challenge if you are part of an active DSC. This challenge is basically a way for students to come in teams and try to build a solution to solve a real world problem. So it's a great way to get some practical experience in building and development. We basically provide opportunities that support students who are passionate about what they do. We try to foster learning, sharing, and collaboration. And if you're entrepreneurial or you have a really good idea that you want to execute, this is the ideal space for students to create and test new ideas that can solve existing problems. We are able to provide a wide range of tech tools from Google, and DSC provides a well-established development platform to help with that creation journey. I know that for myself, I joined in order to gain more technical skills that I wouldn't normally be able to get from my courses and to meet and network with more people. I've also gotten the chance to talk with PSU alumni that are employees at Google currently, and I was able to learn more about Google as a company and what it's like to work there. So if you guys are interested, scan the QR code on the screen, or go to that link under the QR code and you're able to access the registration form for our club.
Also, there are some login, like if you want to be a member, there are some credentials in the chat. So feel free to look at those as well if you want. Otherwise, yeah, it's all good.
Oh yeah, follow us on Instagram and LinkedIn. Okay, so we're gonna start off with a overview of deep learning. This is just gonna be a higher level view of deep learning and kind of why it's popular, why a lot of people are very interested in it right now. All right, so what is deep learning? Deep learning is basically a term that came from a computer model based on neural networks of the human brain. It's structured after what the human brain looks like, and the people that coined the term created the first artificial neural network, or ANNs. And right now, present day, deep learning is usually it's defined as the branch of machine learning that deploys data-centric algorithms in real time. And as deep learning has evolved really quickly over the last couple of decades, I think one of the main things that I want to talk about is how it's different from artificial intelligence and machine learning. So artificial intelligence is a very generic term, umbrella term. It's related to making computers mimic human behavior and make them try to perform human tasks. So any sort of objects turning smart or being able to function on their own can be classified as artificial intelligence, like cars or like smart fridges. They're artificially intelligent objects. Machine learning is a subsector of artificial intelligence. It's an application of AI. It's basically the ability of a system to learn by itself without a human telling it to do so or programming it to do so. And machine learning represents basically a set of algorithms trained on data to make artificial intelligence possible. And lastly, deep learning is a part of machine learning, and it's applied to larger data sets, and it's based on the human brain. It's based on the artificial neural network, and it essentially tries to think the same way that a human would logically think. Yeah, it's effectively mimicking a human brain structure and function. So an example of this would be self-driving cars. And another example that I thought was really interesting that kind of encapsulates all three of these things, AI, machine learning, and deep learning, would be natural language processing. So that's teaching human language to computers. And in certain ways, it falls into all three categories. So why is deep learning popular? So before deep learning kind of blew up, the traditional machine learning methods were mainly used, and those consist of decision trees and logistic regression. So these algorithms are called flat algorithms, which means that it can't be applied directly to raw data. So like images, text, or like .csv files, these algorithms can't be like immediately applied to them. We need to do feature extraction to flat out to the data first, and that's like a pre-processing step. So feature extraction is the classification of the data into several different categories or classes, depending on what you're doing. And that's very complicated. It takes a lot of knowledge of the problem domain. Like you need to know a lot about the subject that the data is stemming from. And there's also a lot of testing that's involved, as well as like fixing it, trying to make it perfect. In deep learning, the feature extraction step is essentially skipped. It's already part of the process that takes place in the artificial neural network. So it's a lot quicker. It's definitely more abstract, but it takes away that very complicated pre-processing step. And another way that it outperforms, I guess, machine learning techniques is that it's very useful if the data set is large. So with a lot of big data now, the deep learning is definitely more fitted for analyzing big data. Small data sets, machine learning is still good for small data sets. All right. So we're going to talk about neurons and the artificial neural network and the basic components of a neural net. So a artificial neural network, first of all, the ANN is made up of neurons, and a neuron is a basic computational unit of ANN. So these neurons are connected using artificial layers, and these layers are where the information and data passes through. As the information flows through these layers, the neural net basically finds patterns between the data, and this is very good for classification as well as prediction. Training a neural net generally takes a lot of time, but using one to make predictions is pretty fast, and it's mostly used when you want to recognize some sort of pattern. There's two types of learning, two different types of learning. There's supervised learning and unsupervised learning. So supervised learning, you know what you're looking for, and you know what patterns you want out of the neural net ahead of time. With unsupervised, you're kind of just letting the neural net run free. It's going to look for previously like unseen patterns or interesting predictions that wasn't there before. There's also unsupervised learning also looks for patterns in data sets with no pre-existing labels and with minimum, I guess, human interference or human supervision. Okay. A little bit more about the artificial neural net. The image that you saw before, that's a very basic one. This is one that only has one hidden layer. And we'll talk more about the structure of ANN later, but this image right here, you can see that there's 3 different layers. Here's input at the beginning and then outputs at the end. So again, it's designed to mimic the human brain, and it learns from previous experiences and then changes accordingly to what it's learned from before. The individual layers of a neural net can be thought as a filter, and the filter increases the likelihood of detection and outputting a better result. So the human brain works kind of similarly to that. When we learn something new, we compare it to previously known information and then makes a decision based off of that. So one more thing, in general, neural nets like these, they perform the same tasks as classic machine learning and like the algorithm that machine learning uses, but that doesn't happen the other way around. So that's why it's such a hot topic right now, and it's becoming a lot more popular than machine learning. So the structure of a artificial neural net, any artificial neural net is basically made of 3 different types of layers: the input layer, the hidden layer, and then the output layer. So inputs, or like data, initially passes through the input layer. There's always a constant set of dimensions for the input layer. So that means whatever you put into it has to be consistent. Like for example, if we wanted to train a model that classifies images, maybe between cats and dogs, the inputs or images in this case, they have to be the same size. For the hidden layer, this is where the computation of, I guess, the use of activation functions, they come in here. And lastly, we see the output layer. So the output layer, that's when we see a prediction and we get a result. And this is also where we are able to classify the data. Okay, next is weights and biases. So weights are integers that control the signals between any two neurons. In this picture right here, all of the little synapses, the thing that connects a neuron, they all have a weight to them. So every neuron inside a neural net is associated with two parameters, which is weight and bias. The weight, so if the output is desirable, if the output is what we want and it's close to the expected value that we want to produce, then that means the weights are ideal. But if the neural net is generating something that's way off, then the neural net needs to alter the weight to improve results the next iteration. So in this picture, again, each synapse has a weight associated to it. On the mathy side of things, the coefficient of the equation that you're trying to resolve, that is the weight. In general, so if the weight, it can be a positive number or a negative number. If it's a negative number, it reduces the value of an output. So we attach weights to outputs because it's reflecting how important that input is. The next parameter, which is bias, it is a constant value or a constant vector that is added to the product of inputs and weights. It's a way for, it's the algorithm's tendency to learn the wrong thing by not taking everything into account in the data. So for the model to be accurate, there has to be low bias. If a data set has a lot of inconsistencies, so maybe missing values or input data is not the same, I guess. What's the word? It's escaping me. The input just isn't the same, then the bias will be high and the predicted values are going to be wrong. So essentially, both of them are really important for a neural net to be accurate. All right. So we're going to talk about the input and feeding forward. So again, input, it can be receiving values from an external data source or other nodes, and the input always has an associated weight to it. The weight will determine how important that input is relative to other inputs. The neural net has to be defined with the number of input dimensions, output features, and hidden units. So these metrics all fall into a basket, which is called hyperparameters. The hyperparameters are numeric values that determine what the neural net's structure is going to be. So first, at least in the beginning, the weights and biases are set randomly, and as it goes through and through, it gets increasingly more accurate. For the hidden layers, so data is sent into the input layer and then into the hidden layer, and the weights are updated for that iteration. Then that creates a function that maps the input with the output data. So this function is the activation function, and we'll talk about that in a little bit. And also for every forward pass, which is where data travels from the input layer to the next layer, a loss is calculated. So the loss is the actual value minus the predicted value. So that loss is going to be sent back in the net, and this is called backpropagation. We'll talk about that. So the neural net is going to be retrained with that loss, and that's how that's another way for a neural net to become increasingly more accurate. So activation functions. The activation functions, they basically perform a computation in the hidden layer and then just takes that result into the output layer. And it's very important to find the right function for your neural net. There's a lot of different types of activation functions, and they all serve different purposes. So in the actual neural net, what it's doing, the activation function is part of the neural net that defines when a neuron is going to fire. So it's kind of like this tipping point. If the input is a certain value, it won't cause the neuron to fire if it doesn't reach that tipping point. But if it becomes a little bit more, then the neuron will fire. So how that's defined, the definition of neuron is y equals the summation of weight times input plus the bias. So this is also why weights and bias are important, because they play a role in what a neuron is actually going to be. This equation computes basically the weighted sum of the inputs, and y which is the output, y is any value between positive to negative infinity. So the problem is deciding on what value of y would become the value that is the tipping point of the neuron, and the activation function will help decide what the tipping point is going to be. The bias is going to shift the result of the activation function either positively or negatively, and if we don't include it, then the neural net becomes like a matrix multiplication, which is weight times input. So that's why another reason why bias is important. If we only do weight times input, it can end up overfitting the data set because you're not taking into consideration of how accurate the model is. So lastly, the activation function determines which value is high or low enough to reflect a decision point for the neuron to fire. And you have to know what activation works best for a particular scenario. And I have an example of 3 of the most popular activation functions. So the first one is a sigmoid function, and it essentially takes whatever input is, and it tries to squash it between a range of 0 and 1. And that is the formula of the sigmoid function. The next one is a tangent function. It's very similar to a sigmoid function, except it has a range of -1 and 1. So it's essentially a method for activating neurons. The only difference between the sigmoid function and this function right here is that this has a stronger gradient. It's able to detect smaller differences easier. So if you're doing classification, it makes the model more sensitive. And then the last one is the ReLU function. It's a linear function that outputs 0 if the input's negative, otherwise it goes positive. And ReLU stands for rectified linear unit. So it takes the input and thresholds it at 0. Any negative values will be 0. Anything that's not negative is a positive number. Okay, I'll pass it on to Sasha to talk about loss functions.
Thanks, Brittany. So loss functions are used to determine the error between our output and the target values, and knowing the error is important when looking for our model's accuracy. So the smaller the error, the closer our model is to the actual target. And 2 of the most popular loss functions include 0, 1, and quadratic, which we'll talk about next. So the 0, 1 loss function is very simple. It is an indicator function that returns 1 when the target and the output are not equal and 0 otherwise. So basically, if the target is not the same as the output, if it's not exact, then we're going to get a 1. And that lets us know immediately whether it's correct or not. And then the next type of loss function is quadratic. It is a commonly used symmetric loss function, which means that The symmetry comes from its output being identical with relation to targets that differ by some value of x in any direction. That just means it doesn't matter if our target is below or above the output, the error is going to be a positive number, which lets us know just slightly different information about our error. And then the constant in that formula that is displayed right there, lambda of x equals c, and then the difference between target and output squared could be anything. Sometimes different values are more useful, like sometimes it's set to half to make it easily differentiable. And Brittany has already mentioned backpropagation, but it uses gradient descent, which is calculated with respect to any weight and bias. So we propagate the error that traverses through each and every layer using this algorithm to modify the connections between the neurons. So once we know the loss, once we know the error, we can see how we'd like to modify our model to make sure it fits our data better. And next, before demonstration, I'll just explain a few TensorFlow basics. So TensorFlow itself is an open source software library for machine learning. And recently it's been more and more used for training deep neural networks, which is what we talked about today. It uses computational graphs, which you'll see in the models. And some of the key basics to look out for are variables and placeholders. So variables can be updated, and placeholders are used to feed data into the graph. So think of any function like y equals mx plus b. Y and x are the placeholders. So we also have constants and operations. Constants cannot be updated, and operations represent the graph nodes. So that's the actual data points. And then graph is what connects all the variables, the placeholders, constants, and operators into one full picture of our model. So now we will move on to the first model presented by Yankee.
Hey everyone. All right, nice. I'll be sharing my screen for this. All right, so I mean, we have a very simple model, and as Brittany and Sasha talked, you can use TensorFlow for many different projects, but for this one, you don't have to use it because we already know how to convert different temperatures to each other. But we just came up with a really simple one for all of you to understand it. And it's really easy to implement. And then the source code can also be found at the Medium's website. So what we have here is that we have a main.python a Python file where it runs through the basic Fahrenheit translation formula, which is a Fahrenheit is equal to Celsius times 1.8 plus 32. But like I said before, you don't have to have a TensorFlow to convert a Fahrenheit value to Celsius value, right? You can easily have a math function and determine any Fahrenheit value that you have. What we have here is that the difference is that we're not giving TensorFlow a specific math function. Instead, as you guys can see here, we're importing TensorFlow, NumPy, create arrays as our dimensions, and matplotlib to graph the epoch versus lost data. So first we create our Celsius array, which, well, you guys can ask, why are you using NumPy? So in this case, we're using NumPy to create our arrays, and our arrays, as you guys can see, is just one dimension. And the reason it's one dimension is because we just have one layer and one neuron. It's a pretty simple project. We give TensorFlow different types of values of Fahrenheit values, and then we have Celsius values. And if you go down, you guys can see how to create a model for our TensorFlow. When you try to create a model for TensorFlow, you might have to use specific functions that is inside TensorFlow, and you have to use something called Keras, which is a side function that enhances TensorFlow applications. It is not something separate from TensorFlow. It is something inside TensorFlow that we use. So to create our model, we say our model, we give it a name, we say our model, I just named it model. Model equals TensorFlow.Keras, we call the Keras function, and then we call sequential, and sequential is a function that takes several parameters. the one of the parameters that it takes is the layers and the units of the layers and the input shape. The units, the red one that you guys see, is the number of neurons that we have for this case. The input shape is the number of the layer, which is 1. And then, like Brittany said in the presentation, we have to have a loss and optimizer function. And for that, we have we call that compile function to create the optimizer. And then we define our loss as mean squared error. And Adam is what Google named its learning rate algorithm. And we name it 0.1. Usually that specific value is determined by scaling large objects through different algorithms. But in this case, we gave 0.1. And you train after that, you train your model after .compile, you train your model with .fit method, which is another function. Which you guys can see here. We named it history. History is equal to model.fit. And then at fit, we have 2 parameters that we named at the first part of the project, which is Celsius _Q and Fahrenheit _A. So we call them, and then you can give any epochs that you want. Epoch is the time. So the more epoch you have, the more data, the more trained your data is going to become. And in this case, we have 500 epochs. And verbose is the argument where it kind of, when you run, I'm going to run it soon so you guys can see it. Verbose just lets you see visually how many of your data is trained. And then we use matplotlib to graph the epoch number versus loss magnitude. And at the last bit, we have our test model function, which calculates our mean squared error. And our, as you can see in the last bit, our predicted Fahrenheit value. So when I run it, it's gonna take some while, but
okay. Really quick, so the epoch, it's basically incremented every time the model goes through all of the samples in the training set. That's what epoch is, yeah. And also in this one, the reason you only see 1 line instead of 2 on that graph is because we are only showing the epoch versus the loss for just the training data. We don't have a testing data for this because it's such a simple model. For testing, we're just using the Celsius to Fahrenheit conversion formula, and then we're going to see how accurate this model can predict a Fahrenheit value.
Here, I'm going to run it again because for some reason it did not print the last one. Okay. All right, there we go. Nice. I don't know why I did that in the first bit. So as you guys can see, let me make this bigger. So you guys can see how many epochs we have. And then this is the Celsius. So basically in the last function, we make a Python loop saying that an iteration starts from 10, and then each time it adds 10, and then we go until 210 in terms of Celsius values. And then we get our basic Fahrenheit values. It calculates it in that function. And then our own prediction, which is right here. So 10 degrees of Celsius is 47.276 according to our machine learning, but in real life it's 50. So we don't have a lot of training data, but this is a really basic way to show how TensorFlow compiles and fits a specific data, especially if you're using a float value using NumPy. That's all we have for this simulation. So
a couple of things to note. First, for this, the graph that we saw earlier, the one that goes like whoop, like that, the only thing that really tells us is that the more iterations that we go through, the more accurate the model is. The more times we run it, right, like the lower the loss is. So that means that the more accurate it's getting. And Yankee, can you scroll all the way down to the end where the mean squared error is?
Yeah.
Yeah,
one?
so I mean, yep. So that's basically showing us that's the average of all of the different squared that you see on the side here. Like is a different squared for each iteration. So that's just telling us that the error, what the average error is, and 2.0, it's not the worst, it's not the best, but yeah, it's like pretty accurate.
Yep. Yeah, that is it for this model. I think Harsh has something now, so I'm stopping
Sure.
it. All right.
Okay. This is from a very common Kaggle problem, which is called the Titanic model detection. So this does not have skills of TensorFlow, but has some essential concepts of machine learning. So as you can see, NumPy, Pandas, XGBoost are three of the most essential libraries that you need to know if you're learning machine learning along with TensorFlow. And what basically NumPy is, it's kind of like allowing linear algebra incorporated within your models and how to make it much more smoother. And Panda is just kind of like reading your data from the CSV files, the text file that you have. So it makes it really easy for the compiler to kind of go about it. And XGBoost, I don't know if a lot of you might have heard about it, but it's a gradient boosting framework and kind of allows a lot of distributed gradient regressions and a lot of understanding towards that. Also, we imported sklearn, which is another model selection software. So our first thing that we did is kind of import the CSV file, that is all the passenger ID with all the labels and their data stuff. And the first thing, so whenever you're trying to work with machine learning, there are always a few things that you need to kind of check or need to do. Like one of the most essential things is probably get your training data, check if any part of your training data is empty and what are those elements and how can that be filled up. So like over here, like we check is like which elements are empty and what are their sums. So like what's their general values of them being empty. So now here we just run like general analysis. So like on just like, okay, so how many passengers were male and how many passengers were female. So that was just some basic analysis. And then we found something on train survived. So if it's zero, then there's like 49 people had lost their lives and 342 had survived. And the same goes over here, where you're categorizing more in terms of their survival and their gender. So again, as you see, zero is for someone who's died, not died, and one is for someone who died. So now we try to find the average, so which is another mean, which is like a general mean. So these are some of the common keywords or terms that we would kind of use to call that is imported all from NumPy. So NumPy is a um, very essential library when you're working with machine learning and data science. And here again, we call the mean function again. And now it's the the age, where we kind of distribute everything on the basis of age and all the other categories that we have kind of specified. So I'm sorry. So now it's like extracting all the titles, all the um, information from all the passengers and whatever the title that they have. So it's kind of like and here we kind of just replace all the titles and then just see how everything looks, because there are often at times when we want to try to change and make it more presentable. So that's when we kind of do this. So now getting to the more fun part. Uh, so over here, we're trying to create the two models, which is like the X coordinate and the Y coordinate, as Yankee had shown in his temperature conversion machine learning model. And that's what we're trying to create, is where we have X for depending on their age, gender, and stuff, and Y is we're trying to create something based on their survival rate. I'm sorry. So this is what we've done so far, and what we're trying to do is we're calling the XGBoost library, where we're trying to extract all the data from, which is like a gradient boost framework, and where what it's trying to get us is how the values are going to depict on the graph. And then we kind of predict how the score of the model is, which is model.score. And this is just like as Brittany mentioned in the slides, that the closer you are to 1, the better is your accuracy of your model, and the better it looks, and the better it's going to function. And same you would do for the like how we had kind of found about hyperparameters for the classifiers over here. So what hyperparameters are? They're parameters that are extracted from the previous parameters. So it's like parameter in a parameter, if that makes sense. Okay, and now we kind of predict the model and like apply all our model to the data, and that's the output that you get. So this comes out in the form of an array that would look on a graph. So that would kind of be like a 0 1 0 1. So they're kind of showing like deaths, like didn't survive, survive, survived, didn't survive. So yeah, that's how it kind of would run. And one more thing that I would recommend is that if you're working with machine learning, definitely maybe use like Jupyter notebooks or Google Colab notebooks, which are like extremely essential because it allows a very step-by-step detailed understanding of how your code is working and where you're going wrong. So yeah, that's all from my end.
Okay, cool. And then I'm going to share my screen again. Last thing, I want to share some resources that is offered by Coursera for people who are interested in machine learning. Coursera is offering a lot of different like certificates up until December 31st of this year. So this link right here, can one of you guys drop in the chat? This link right here, if you go to it, there is quite a few courses that you can take for free. And that includes AWS, Google, like machine learning with AWS and GCP, which is Google Cloud Platforms. There's also an opportunity to learn C++, MATLAB, and some data science. So take advantage of this.
And the link is there in a minute. I am on it.
I got it, Harsh. I got it.
Cool.
Awesome. And yeah, I think we're nearing 45 minutes. Give some time for questions. And also, so our club, Developer Student Club, I mentioned we offer quick labs, and one of the quick labs is using TensorFlow on Google Cloud Platforms. So you can check out all the different quick labs that Google offers at that link right there. You do have to pay for it. So another reason to join our club, you get to access them for free and play around with TensorFlow. And that is all. Thank you everyone for coming. Open to questions.
Yeah, this was a great workshop. I really enjoyed it. We can stick around for a few more minutes. You guys have till 7 if you want to. We'll see if people ask questions. And then we'll wrap it up for the night.
Sounds good.
And for the attendees who watched who might want to access this later, the workshop itself is recorded and will be put on the YouTube. So take a look at that to get all these resources after this event.
Guys, feel free to text us anytime, join group me, message any one of us personally. We're happy to help. And we're always there to support you. So let us know if there's any kind of support that we can provide you. So see you guys soon.
All right, it looks like people are starting to filter out. So I'm going to go ahead and stop the recording here.
Really quick, I think Nathan, the link for the resources, it's the Medium link. I think if you scroll up a little bit, it says medium.com. That one is one for all of the free like certificates.
My apologies.
Okay.
Yes, my computer has officially got messed up.